So this really simple equation is actually what helps us know if something's spontaneous or not. Remember that when delta G is negative, it's spontaneous, and when it's positive, it's not. So I have this little trick for remembering this equation. Of course, you've got like data sheets and stuff, but you've got so many equations. Or if you take like a test in the future, I used to make up this word G hats, like gadzooks, but G hats. And the negative was the negative in the H. And for whatever reason, that really helped me remember this equation. So there's that. There's a few things to remember about the equation. You want to remember that this is supposed to be in Kelvin. You want to remember that this thing is going to come in as a unit like this, but you're going to have a problem with consistency with this unit. So you need to make sure that you put one or the other of them in the unit you need them to be in. Most of the time it's useful to change this one up to kilojoules, but depending on what you're solving for, you may have to change one of the others. And then this one comes in as a kilojoule per mole also. And the big thing on this one is just making sure you don't lose your sign when you're solving it. So let's go ahead and solve one of them for G. And here's an example. You might have like, it might be like this, and then it might say that the temperature is, like 25 degrees Celsius. And we keep using that one, so there might be other ones, so don't let that throw you off. But that's an easy one for people to remember, because it's really easy to remember that you add 273.15 and you get your 298.15. So I'm going to plug these numbers in. So really this is all about just plugging and chugging and watching your units, just like everything else in general chemistry too. So 298.15, that's Kelvin, times my S, which is 250 joules per mole. And again, I'm going to go ahead and just fix that right then. So in 1 kilojoule, I have 1 times 10 to the third joules. And that's going to give me my delta G value. So I just need to bring over my calculator, and then I'll solve it. So I have 100. I'm going to clear that so that you can see it. Oh, trying to clear it. But I guess I'm not clearing it. 100 minus 298.15 times 250 divided by, I can do 1e to the third, or I could just do 1,000 if I wanted to. And so that gives me that my G value is 25. And since I did this conversion, first of all, my kilojoules, I left it out, but there was a kilojoules in here. I mean to say Kelvin. There was a Kelvin in there. And that Kelvin canceled with this Kelvin. And so that, since I did my joule canceling, that left me with kilojoules per mole. So it's 25. And if this were 100 dot, that might make things a little bit clearer. But I'm going to go ahead and just round it to 25. And my unit is kilojoules per mole. If it had asked if this was spontaneous, you could have just answered it and said no. The other part of these is that you also might have to solve for one of the other parts of the equation. So just as a reminder, if you have delta G equals delta H minus T times S, and you need to solve for H, I would just move this term over to this side. So you would just do that by adding your TS. And so you would have G plus TS, T times S, is equal to your delta H. And so that's rearrange to solve for that one. And then over here, if I needed to rearrange it to solve it for S, so I would start with this. And if I want to solve for S, then I'm going to probably try to get this whole term by itself first by subtracting delta H from both sides, so that I have delta G minus delta H equals minus T times S. And then I divide both of them by negative T. And that way I'll be solving for S and not negative S. And so that's what this is going to be. G minus delta H over T. And you don't have to keep the negative by the T. You could like put the negative in the front, whatever you like. But that's rearranging it, solve for S. Be very careful right on this one, making sure that you realize that that's kilojoules per mole. This is kilojoules per mole, and so you are going to get an answer as kilojoules per mole, and it usually, these problems will say answer in joules per mole Kelvin. And then again, be careful on this side, because again, that's a kilojoule per mole. This is a kilojoule per mole. And this one is going to be a joule per mole, right? So even when you rearrange it, your kilojoules per mole are going to be right there. And then your TS is going to be dealing with that kind of a unit. Once you get your, it has a Kelvin unit to it, but because you're multiplying times T, the Kelvin unit of it's going to be canceled out. But you'll notice we have some unit inconsistency issues there also.